Hello and welcome. Today we are going to be answering a question from your homework on forces and free body diagrams. It says, four forces act on a hot air balloon as shown in the diagram. What is the magnitude of the resultant force and what is the direction of the resultant force? Okay, remember that a resultant force is what we get when we combine more than one force vector. And so in this case, we're going to be combining four, but we're not going to combine them all at once. We're going to first combine the x dimension, and then we're going to combine the y dimension, and then we're going to combine those two dimensional vectors to get the overall resultant. And I'll walk you through that. So what we see is that we have a vector of a force. We have a hot air balloon, and we have some different forces acting on it. 301 newtons to the left, 887 newtons to the right, 287 newtons downward, and 664 newtons upward. And so we're going to, first let's get our x-dimensional resultant force. So in the x dimension, since we have 887 to the right, we have a force in the x dimension of 887 to the right, and so I'm going to call to the right positive. And then I'm going to add a negative vector since this one is to the left. So instead of adding a negative, I'm just going to subtract 301 newtons. And so in the x dimension, we have 887 minus 301. Crunch that on your calculator real quickly. 887 minus 301 looks like 586. All right, and so 586 newtons to the positive side or to the right. Now in the y dimension, I'm going to have 664 upward, which I'll call positive, and then add a negative 287 downward. And so in the y dimension, we're going to have, let's see, 377. 377 newtons upward, or in the positive direction. All right, and so now in order to get my overall resultant, even though the way those are acting, they're acting as if we've got a 377 upward and a 586 rightward, we cannot combine vectors tail to tail. So what I'm going to do is I'm going to slide this vector over and attach it head to tail like that. Let me just clean this drawing up a little bit. And so we'll have 586 to the right, and then attached correctly we'll have 377 newtons upward. And so we'll look at that, and then our overall resultant will be from the start of this vector to the finish of the other vector. And when we do a squared plus b squared equals c squared, we will come up with 696.796. So I'm just going to round that to 697 for the purpose of writing on my screen here. You, of course, should not round when you're doing your homework. So 697 newtons. And then the question is, what's our angle? Okay, now normally, and so what I want to do is I want to use our two originally calculated sides. And those are going to be 377 and 586. And that's going to be the opposite side and the adjacent side from our angle theta. Now, usually you know that tangent is tangent of theta is equal to the opposite over the adjacent side. And it turns out that if we take the inverse tangent, or tan -1, of this number, that will give us the angle. So what I'm going to do is I'm going to take the inverse tangent -1 of the opposite side, which is 377, and divide by the adjacent side, which is 586. And when I do that, that will give me the value of theta. Okay, so we're going to use our inverse tangent function. I'm going to punch that number up on my calculator real quick and see what we get. And after checking on my calculator, I got that theta is equal to 32.755 degrees. And so I would be ready to put that in my calculator. Again, we haven't worked with inverse tangent before, but it basically is the undoing or the reciprocal operation, the inverse operation of the tangent function. So normally you have a theta and you get a ratio. In this case, you have a ratio, and by doing the inverse tangent, you get a theta. So that is okay. Just punch that in your calculator and get that value. All right, I hope that was helpful, and have a great day.